Okay. Morning, everyone, and welcome to our machine learning class. And happy for the beginning of the semester, right? So before we start, I would like to give a brief self-introduction. So my name is Shandian Zhou. I'm a professor. Well, I'm no longer assistant professor. I'm associate professor at School of Computing at University of Utah. So my research area, for sure, is closely related to machine learning. Actually, I'm doing machine learning for 15 years and more. So I've been in this area for such a long time, but I always keep my passion. And it's really exciting. It's really growing area. So I mean, nowadays you might have heard of a lot of buzzwords like artificial intelligence, AGI, artificial general intelligence, and all kinds of words. Unfortunately, I mean, honestly, I think those are just some kind of new hype um, for advocating AI. But the main horsepower or the only driving force underlying this word AI, this new buzzword AI, is actually machine learning, or more specifically data-driven machine learning, who makes this prosperity or research of AI again in nowadays. Hopefully, it's not again a bubble like 20 years ago or 30 years ago. If I'm taken some like general introduction of artificial intelligence, you should have heard of some like waves of the artificial intelligence, right? It has some like when it was created, it has some kind of like a peak. I think it's during 1950s to 60s, and then it goes down, and then research at 1980s and goes down. Now it's the third wave, right? And hopefully it won't, disappear or or vanish so quickly, because we do see some amazing progress of the modern applications like in face recognition, in generative models, and also ChatGPT, large language models. It does provide some kind of like amazing progress and applications, right? I do hope it won't be just a hype, right? So, okay. So, what is our today's topic, right? So, I'm gonna briefly introduce what is machine learning, right? What's the general definition of machine learning? How should we understand the concept of machine learning, right? What's the difference between machine learning and human learning, right? And then I would like to briefly brag about my area, because although it's already very hot, but I still want to emphasize it is now so important and so close to our real lives. Maybe you have realized, or you have not realized, machine learning and techniques have already penetrated our daily lives. Not only just ChatGPT, or you see many fake videos or cool videos, maybe you can call that, right, online, but actually many daily operations like your email box, right, or when you drive a car, they are all embedded with some kind of machine learning techniques which were invented maybe 30 years ago. You just didn't realize. And then in this week, we very probably won't talk about the details about the course content. We're gonna specify the course requirement and policies, especially how many homework assignments, projects, final exam, etc. The goal is that, okay, I want to give you a comprehensive overview of this course structure and policies so that you can make a wise choice at the end of the next week. And also you might have noticed that we released homework 0. Homework 0 has nothing to do with the main course content, right? It's just a quick review of what you have learned before. We assume that you have well satisfied the prerequisite. Like some of you might just ask for a permission code, but I do believe you have enough background for that. But for homework 0, you'll see there's a bunch of like questions asking you to review the basic concept about statistics, about linear algebra, and about several calculus, right? This is like very important for us to go with this course. Otherwise, you might feel like very upset about this class, right? But meanwhile, if you feel sick of those problems, right, in homework 0, or feel very difficult, very time consuming, it might also provide you a chance to reconsider whether you're going to take this class, right? So I really don't want any of you like feel being tortured for this class, right? And there are always like some students like complaining, okay, this course is too hard. This course, the workload is too heavy, and this course should worth like 4 credits or 6 credits, right? This is something I cannot control, right? I cannot control whether this course should be 3 credits, 4 credits, but I just want to give you a sense. This is not just a very light introduction course. We're gonna introduce all the important fundamental machine learning algorithms, and we'll ask you to implement those algorithms from scratch. We're not gonna provide you with some coding template. You should implement from scratch by yourself. Right? It's not like undergrad, very junior undergrad course. I give you a Python template to just fill out blank of several code. It's not like that. Right? It's actually very near to practice, because all the data we give you is some real world benchmark data. Those data set is small, but it's practical enough, and it's also clean enough for you to check the correctness or validity of your implementation. This is not a toy class. Okay. And then we're gonna give a quick review of basic knowledge. That's mainly about definition about random variables, basic concepts like mean, variance, independence between random variables, and so on. Again, this is not comprehensive. This is just a quick refresh our mind and help you to recall the concepts which you might have learned a long time ago, right? And this is just a kind of like help you or give you a lead and help you to retrieve those basic concepts you have learned before, right? And if you feel uncomfortable about something, like it's better for you to open some like old textbook or search on Google to clarify some basic meanings, because after that, we're not gonna review those concepts again, right? We're gonna talk about, okay, say, sample complexity bound, and definitely needs you to understand what's the meaning for expectation, what's the meaning of the variance, right? And those kind of stuff, right? And meanwhile, this is kind of like a coordinates with the homework 0, right? It's just help you to recall and reinforce your past mathematical stuff you have learned. Okay, so first, let us talk about what is machine learning, right? So I'd like to give a relatively formal concept about learning and machine learning, right? And before that, right, I want to play a game, right? So this is a game where it's played 30 years ago by a set of top machine learning researchers. At that time, I believe machine learning, this whole discipline is still at the baby stage, right? Not too many people are there and are not receiving too much attention, right? So in 1994, which is right 30 years ago, right? There's a top machine learning conference. It's called CODE. It's still like top machine learning theory conference right now, right? So attendees of that year's conference, they received conference badges, right? So the badges, whenever you join a conference, you already have a badge with your name and your affiliation, right? And your title and so on, right? But now these badges were labeled as positive and negative, right? It's just some label. It doesn't mean you're a bad guy or a good guy. It's just some kind of label. And there's only one person in this conference who knew the underlying function that generated the labels for all the badges, right? And what we can know is that what people what attendees in that conference knew is that, okay, this function only depends on the attendee's name. So then the attendees are assigned an interesting task, right? So you should talk to as many other attendees as possible and collect their names and labels, and then find the unknown function which generates the labels. Does this sound clear? Right? Does this game sound clear? Right. So now let us assume that, okay, we can travel back to 30 years ago for that relatively small conference, right? At that time, at that year, right? So we have collected a set of badges and the names, right? And by the way, those names are all the big names in machine learning area right now, right? So we have these names and their labels, right? We have Peter Bartlett, positive, Emma Jordan, positive, and Claire Cartier, negative, Eric Baum, negative, and so on, right? So now, I will encourage everybody to look at those names and labels for 30 seconds and try to figure out the underlying function which generates the labels according to the names. Okay. So any idea? Any guess? I mean, you can freely propose your thought. Okay. 12 characters. You may have the thresholding about the name length, right? You mean shorter name will have a negative label? Yeah, that may be a good suggestion. Although we need to check the threshold, right? You mean it's 12? Yeah, probably we need to count. I know. Any other suggestion? Can you see it again? Yeah, that's another. Yeah, that's another rule. And yeah. But again, we need to check, right? We need to count the number of consonants and vowels, right? Okay. Good idea. Any other suggestion? Even odd number of letters? Oh, yeah. That looks a simple but exact match, right? Okay, excellent. Any other idea? No other thoughts? Someone want to say something? Okay, yeah. Thanks for proposing, right? So proposing those cool ideas. And if you're interested, anyone who are interested in this can email me and I can give you the ground truth. And after the conference, I mean, they kind of released what is the ground truth function, which generates the label. And some of you might have like already decoded the function which kind of exactly match the labels. Right? So, but it doesn't mean like your proposed function is really the ground truth function. Right? This is actually a very important concept because right now only have in machine learning, because right now only have like 1, 2, 3, 4, 5, 6 badges names, right? So probably you might have like 1,000 different functions which can all give exactly correct labels for those badge names. Right? But what if I increase the number of the badges and the labels, right? Will your proposed function still exactly match, right? So that relates to the so-called generalizability issue in machine learning, which we'll talk about in detail. But here, we just give you a concrete sense about how you're gonna learn something from data, right? So if we replace you guys, right, by some machine, and then feed the machine with this 6 examples or even 60 more examples, like 60 examples, and if the machine give back you some kind of function, generates those labels, this procedure is called machine learning. Okay. So playing the batch game is a typical learning procedure. Why? Because you're given some data, right? And given some label data, you're given some training instance. Right? You have a instance 1 and label, instance 2, label, and so on. Right? And then your outcome will be some function or some procedure, so such that when I give you a new instance, you can use your procedure to tag that instance, right? So this is called a learning procedure. And later we're gonna give a more formal definition of learning, right? So if the players are machines, it is a machine learning procedure. Okay, so I want to highlight that there are many machine learning tasks, right? Which sounds much more complex, much fancier than the aforementioned batch game, but they essentially execute the same learning framework. Namely, I'm gonna give you a collection of labeled instances and train you to capture some underlying complex mappings, relationships, such that you can better label or better predict labels for future instances, right? So here we want to give some like fancy examples. One is called chess game, right? Go game. And how many of you have heard of Go games before? Okay, perfect. And the Go game was viewed as the world's most complex games, mostly because it's possible space. By space, I mean, okay, because you see that you have white chess and the black chess, right? You can play it anywhere in this chessboard under weak constraints. There's some kind of like constraints, like in some places you cannot place, some places you cannot, but it's very weak. And then, but this whole chessboard has 90 by 90 grids, right? There are many choices, and imagine that you place one piece here, and you can freely place another piece at another place, right? You just keep doing until you know who wins, right? White wins or black wins, and such kind of possibilities kind of is huge. Number of possibilities is huge. Actually, is many orders of magnitude larger than the total number of the atoms in the whole universe. So it's it was like 30 years ago, like people will never think about, okay, sometimes like computer programs will beat human players, right? And until several years ago, and this AlphaGo program developed by Google has been able to defeat the best human player in the world, right? So that's really a big win of machine learning. And if you're interested, you can take a look at the Nature paper published by Google. They're talking about how do they do that, right? So the basic framework was invented many years ago. It's called Monte Carlo tree search, right? But they have used deep neural nets to help better capture or quantify whether a particular layout of those pieces, white pieces and black pieces, will help you predict the future chance of your winning or lose. And then they use a super large computer clusters to help you to let the computer to play with each other until you know the final win or lose. So another typical example is about the generative models. I assume that everyone has heard of that, right? Has anyone never heard of this generative model before? Okay, so I was strongly suggest everyone, like, if you look at Twitter, if you look at the recent tweets from Elon Musk, I don't know if it's his own company or group, they released their video generation software. They're generating a lot of like interesting videos, right? Some of them are making fun of American presidents. If you're interested, it's very funny. But without, I don't want to offend any of those public figures, but you can take a look. Those are just generated by computer programs, right? And most but if you also look at the website, look at Google image or whatever search engines, and you will see a lot of like automatically generated images from this so-called generative model or diffusion model, right? You can give a short description of the text, right? Say a photo of some kind of dog with backpack riding a bike, right? So it will automatically generate figure. It's not created by human. It's generated by figure. And that's actually, it can generate pretty fancy figures. And this is not just for fun. This is actually very useful for applications like game design or even some kind of art design. People are trying to use computer generated figures, right? So this technique is called conditional generative models. Right? It's kind of like one of cutting edge research and development in both academia and industry. And there are many other applications which do not sound very cool, but you might, but that actually is along with our life. Like, for example, when you buy things in Amazon, right? When you watch videos in YouTube, and especially for YouTube, like when you watch some video, they're gonna always recommend some videos to you, right? So I don't quite much like their recommended videos because the quality is not very good to me, but they're based on some machine learning technique. So if you purchase things on Amazon, they're always trying to recommend you to buy additional, right? It's kind of annoying, at least annoying to me, right? But this is their major way to earn profit, right? So those are based on machine learning as well. And actually, they hire a large group of machine learning engineers and researchers. They develop a smarter recommendation system and to recommend you and to earn more of your clicks and purchase behaviors, so they can earn more from the the sellers and advertisers. And this is about autonomous driving, right? So how many of you have heard of FSD from Tesla? No one heard about that? Okay, there are like tons of videos in YouTube or showing that, okay, if you drive with your Tesla with FSD open, it seems like work really well in autonomous driving, right? Even in dark side or even in raining situations, right? And the most amazing part of FSD the software in Tesla is that it is purely based on vision system. It's like you have like 8 cameras installed in your Tesla, and probably has a very low precision radar, but it's not like laser radars, which is very expensive, right? And they mainly use like images taken in real time by those cameras, and then reconstruct the 3D environment, and then do the prediction and do the decision. Those kind of, it's really amazing. But right now, I believe it's still like a little bit not sufficient from like full autonomous driving, right? Although the Tesla, they officially just came, okay, we're close to full autonomous driving, and we're close to like even doing like robot taxi, right? But I would see that achieving such amazing progress is also attributed to machine learning, right? Especially the progress about the deep learning, reinforcement learning, and imitation learning. Okay, so actually machine learning is everywhere. Here we list a bunch of other applications like spam email detection and tagging people in the photos, right? Whenever you use iPhone or use whatever digital camera, right? When you take picture, there's some kind of small bounding box, right? Bounding the face, right? So this was mostly implemented by the algorithm called ADA boosting, invented about 30 years ago, but it's very widely used, very successful, which we're going to discuss in our class, right? And movie recommendation and a product recommendation, predicting stock price, right? This is very hard, but actually in hedge fund, reinforcement learning is a very often used strategy to help you to make the policy to purchase those stocks and sell them in a short time. It's a very popular strategy. Handwriting recognition, right? So nowadays when we send a letter, and they're gonna, the machine in the post office will first help to identify the address and also the postal code, right? And advertisement placement, right? This is kind of most annoying application of machine learning. Unfortunately, it is the majority profit source of major internet companies, including Google, Alphabet, and Meta, and Amazon, right? And translation, right? Translation, I don't know, how many of you are frequently using machine translation? Okay, good. And I use this very often because my mother language definitely is not English, right? And every time when I read a paper, when I write paper, even I write a rebuttal, I would just use a Google Translate to help to look at, okay, whether my English writing is good enough, right? The one way to test it is that, okay, I'm gonna write a piece of English paragraphs, right, and paste it into the Google translation box and translate to my mother language, Chinese, right? And I read my Chinese translation and say, okay, this is good. Then I will like, oh, this is good English. That's the way I use that, right? And actually, it's pretty convenient. It's pretty neat, right? So maybe you have never tried the Google Translation version 20 years ago. At that time I was just a master student, right? At that time, the translation is not working at all. It's very, very bad, right? But now you see the technique improvement. It's really amazing. And another wide application and also development about machine learning is the usage in the drug discovery. So maybe this is like less known, like many startups right now, they're trying to use machine learning technique to help us to identify what is the appropriate drug design, also molecular design to bind some, I don't know, like molecular drug molecules to help it to better be absorbed into the human body and so on. And this will expected to largely accelerate the development procedure. Otherwise, you have to, use clinical trials and animal trials to determine whether this is good or not, right? It's very, very time consuming and also costly. Okay, so now after bragging about the importance and popularity about machine learning, which is my own area, I hope everybody will enjoy this area or feel this area is promising, right? And we should circulate back to the basic question: what is machine learning? Right? So can we give a formal definition of machine learning? Right? So we're gonna we're gonna start from like very beginning of the artificial intelligence, the machine learning, and give a very preliminary definition to and proceed to a more formal definition, which is more widely accepted, right? So in 1950s, right, this is like one pioneer of artificial intelligence who has passed away, right? And by Arthur Samuel, he gave the definition of machine learning as follows. So machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Okay. So this is more like a implicit or indirect definition, right? So remember our badge game, right? If I give you 6 instances, right? And you can write a program, right? If else, if else. If the name is this, and I'll give you positive. If the name is that, I'll give you another label, right? So I can also exactly recover labels for all the 6 names. But would that program called be a machine learning program? No. Why? Yes, because it explicitly program, right? In other words, you explicitly memorize the so-called data or training instances, right? You cannot generalize to new instance, right? For example, if I give you my name, right? Tianyan Z, right? I can give you the label. You cannot, right? That's difference. That's the difference from the explicit programming, right? You must make your program to abstract some common patterns which can extrapolate to new cases, which we call the ability of generalize. Right? Then we can call this is machine learning. Does it make sense? Okay, so now let us proceed to a more modern definition proposed by Simon, right? 1983, right? He said that learning denotes changes in the system that are adaptive in the sense that they enable the system to do the task more effectively next time. Right? This kind of talk about another aspect of learning, meaning that, okay, when I absorb some kind of training data, right, or instances, I can do the same task more efficiently or more effectively, right? So it's like some kind of imitation of human learning behaviors, right? When I got trained, I can do better for that particular job, right? But it's still kind of like not that concrete, right? So now let us look at more widely acceptable definition of machine learning, right? Learning as a generalization, right? This is given by Tom Michel, who is the department chair of the machine learning department in CMU. Right? The definition is as follows: a computer program is set to learn from experience E with respect to some class of tasks T and performance measure P if its performance at task T as measured by P improves with experience E. Okay. So it sounds like a tedious definition. Right? It's lengthy, but actually it introduced several very important components in machine learning. First, E here, although he mentions this is called experience, but this is actually the training data. And tasks T just represent the type of tasks you want to learn. Right? We need to specify the range of tasks for which we expect to improve from machine learning, right? And we have a measurement P. So you must have some measurement metric, right? And which can tell us whether your machine learning performs well. Right? So from Tom Michel's definition, it just tells that, okay, what is machine learning? Right? If you feed some training data to your machine learning program, then we expect your machine learning program can improve in doing some particular type of tasks. And this improvement can be quantified by some measurement. Does it make sense? Right? Any question? Everyone feels comfortable? So why we want to highlight, want to emphasize this definition, because it actually summarizes all the important components in machine learning, right? What is the data? What is the particular tasks or particular type of tasks you want to do? And what is the performance metric, right? These three things are indispensable for every practical machine learning task you want to address, right? So I would request everybody to keep that definition in your mind. Right? Okay. A more straightforward implication of the Tom Michel's definition is that learning is actually equal to generalization, or learning is ability to generalize. So giving you a collection of pictures about dogs, right? So if you just memorize those images, of course, when you pick out any image and present to your machine learning algorithm, it will tell you, okay, this is a dog, right? But we also want a different dog image can be recognized by our algorithm, right? This is called machine learning model, machine learning algorithm, machine learning program, right? You must gain some kind of generalizability. And actually, the research or the development machine learning is always trying to make your generalization capability larger and larger, or more powerful and powerful, right? And we hope that, okay, given the same set of the data, right, you can gain the best generalizability. That's the goal of machine learning research. But unfortunately, not, I mean, different algorithms, they have different generalizability, right? So maybe for algorithm one, recognizing this new dog image is a piece of cake, right? But for algorithm two, it's hard. But it's relatively easy for that algorithm to recognize another puppy image. And we'll see that some kind of mathematical framework, how do we quantify or characterize the generalizability of your machine learning algorithm. Okay, why do we study machine learning? Because it's popular, because it's important, and it gives us some kind of promise to build computer and programs with new capabilities, which is really can only be done by human beings, right? And it can also help us understand the nature of human learning. And our ultimate goal in machine learning and also in artificial intelligence is to develop robots that can learn as human beings, right? I don't know whether it's a good goal or a bad goal, right? There are obviously, the whole society has raised some concern about doing this, right? But from researchers, right, from scientific community, people are more interested in, okay, develop robots kind of like help us to release our labors, right? And to let us to do more creative, to more fun things, right? And then like robots to do something other, more tedious or, you know, other massive works, right? Right. So from my understanding, machine learning is the future, right? So because right now, this is a time of big data, right? People are accumulating data everywhere. People accumulate data for every area, right? So this data actually represents the experience, the accumulated experience. And if we don't leverage it, it's kind of waste, right? So hope that to leverage those past data to help us to build up a powerful algorithms and automatic procedures to do things automatically, right? And so that human beings are able to deal with more advanced things, more imaginating, more things which is more creative and more fun. Okay. Okay. So far, any questions before we talk about the course structure and policies? Any question regarding the general concept about machine learning? Okay, great. So now we would like to spend a while talking about the design of this course, the structure of course, and the requirement of this course, right? So first, we would like to emphasize that this course is entry-level machine learning. You have known that from the, course catalog and the basic introduction in our course website, right? So this course focuses on the basic concepts and algorithm ideas in the field of machine learning. This course is not teaching how to use a specific machine learning tool. Like, I know some of you might be very fascinated about how to leverage, how to use PyTorch, or use whatever popular machine learning tools. Unfortunately, this is not the goal of our course, right? And this course will not focus on single learning paradigm like neural networks, right? So we'll introduce some basics about neural networks, but it's very fundamental. We're going to talk about what's the design philosophy of neural networks. We're going to talk about how to do backpropagation, right? And you are required to implement backpropagation by yourself, right? However, we're not introducing more advanced neural network architectures like attention, like convolutional neural nets, and like transformers and those kind of stuff. So we'll leave it. We'll view our course as kind of like a fundamental or cornerstone for you to proceed to more advanced topics. But if you're particularly interested in one type of machine learning tools or paradigm like deep learning, in our department there are some more advanced courses called I think it's called deep learning. Right? You can register that course for sure. Okay, so any question regarding yeah, thanks for sharing your thought and experience. Yeah, I believe our department is trying to open a more practical machine learning course. Basically, like, okay, I want to teach you to quickly build up a deep learning model and take a while, or build up some kind of other learning algorithm using some existing libraries. They're trying to create such a course. But right now, for our class, we want to introduce, if you just, you have already had some experience, right, in doing machine learning, especially deep learning, that's a great experience. But we want to give you some like fundamental concepts. So what is training error? What is generalization error? What's the difference? What's the relationship between training error and generalization error, right? And what's the underlying mechanism of the deep neural nets? Like all deep neural nets are based on the so-called backpropagation. But what is backpropagation? And how do you implement backpropagation? Do some focus on this class. So we want to Some papers are really good at it. How they're determining what is good. Yes, different. Yes, very happy. That's what give you, yeah, that's hard to learn by yourself. Yeah, I think papers, they won't tell you this, they assume you know that. Yeah. But we want to give you what is on the line, right? Why you should use RMC, why you should use MS, why you should use absolute array. They're actually different than, so, yeah. Again, yeah, I want to emphasize that this class is more fundamental. And I want to emphasize that we want you to know many important concepts which might be missing in tutorials or quick courses. I mean, I'm not saying like those courses are bad. They're good because they can help you to quickly pick out some tool and run something and get something useful. But if you want to deepen understanding of this area and not misled by some kind of claims, this is what our class want to address. Okay. So how we will learn, right? So this is always what I suggest if you want to do well in this class, right? So take classes to learn the models, algorithms. And I know this today and perhaps this week, I will have the maximum attendance in my class. And then after that, I mean, less and less students will join, and probably at the end or near the end of the semester, there will be only 12 students or 17 students joining the class. But I want to still emphasize that if you got some time, if you got some chance, please join the class in person so you can interact with me, the instructor, directly. That will be more efficient. Of course, we're trying to, release the course videos and record them. And in case you cannot join, and I want to give you the most convenience, right? But for you, like, if you can effectively take this class and interact with the instructors, you don't need to spend too much time under that, right? Except doing homework, right? And given that later, I want to emphasize the workload of this class might be a little bit heavy, right? I want to save your time. I want to make you feel you're learning very efficiently, okay? So this is the first suggestion. And the second suggestion, of course, is to finish the homework assignment and the project assignment in time to deepen your understanding, right? So we see that our homework assignment is usually partitioned in two parts. One part is written assignments. It's just to recheck the math and algorithm part we discussed in class. You have fully understood, right? And then we have program section, and typically we'll provide you some data set which we have already processed, right? And you're going to implement the algorithms we have discussed in the class and test them, and until you feel okay, your implementation is correct and the result is reasonable. So such implementation will definitely help you understand those model and algorithm, and help you understand how those algorithms really work when applied in practice, right? Sometimes you'll see that, okay, in the class, we'll see this algorithm table, for example, I will give you a table about data boost, right? You feel, okay, so simple, right? It looks so comfortable, right? But when you implement, you feel all kinds of weird things, right? And in most of the cases, is that, okay, you probably made mistakes, right? Which you might feel silly. but it is very often, even for experienced machine learning engineers, they often make mistakes, silly mistakes, right? And then make the algorithm not working as you expected. So that's why we kind of emphasize the implementation, right? You should be able to convert what you have learned in your mind into practice, into the code, right? And do the course project, right? So doing course project, which we'll discuss later, this kind of open course project, you can pick out whatever project as long as reasonable. It involves machine learning technique. We're not limited to any machine learning technique. You can use machine learning techniques we taught in the class. You can use open source machine learning tools. And if you have some experience and previous experience in running deep learning libraries, that is fantastic. Leverage and give your experience and give your share with us your results. Like that is just trying to enlarge your practical experience in doing machine learning. Does it make sense? Any questions so far? Okay. Okay. So now it's more critical point, right? Workload, right? So we'll have in total 6 homework assignments, including homework 0 released today, right? So usually it's about like 2 weeks, 2 to 3 weeks for you to finish the homework assignments. The time should be sufficient, but it usually won't be possible for you to finish at the deadline. I mean, if deadline is Friday, if you start working on Thursday, it usually won't be sufficient. That's why we kind of encourage everyone to start doing homework early, especially the programming part, right? Maybe if you're really good and if you're super confident about your learning and also programming capabilities, well, you can ignore what I said, right? But in most cases, right? In most cases, my experience, I'm teaching this for years, right? The most successful students are who always try to do this early, right? At least for the programming part, you should start like a week before the deadline. The reason is that you need some time to debug your code, right? And many students they came to office hours complaining, okay, I implemented exactly as what you said in the class, but it doesn't work. Can you tell me why? I can't tell you why. It's very probably you just made some mistakes in implementation, right? Very subtle mistakes, right? And I can give you some guidance. Sometimes I can help you walk through the code, right? But I cannot guarantee in 10 minutes I can find out about, right? You have to debug every line of code one by one, look at the variables and look at whether it behaved as you expect. And many students came to me, okay, after fix this small bug, it works. As normal, it works perfect, blah, 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 right? So that's why you do need to allocate enough time to do a homework, right? So don't try to finish everything, in the last day, right? That won't work, right? And don't feel frustrated, right? And later we'll talk about, we actually have office hour every weekday. And of course, we on Friday, we will have like 5 hours for office hour. And we know that many students, they still try to leverage the last day of the to do homework. That's why we try to allocate as much office hours as possible on Friday. But still, we kind of recommend everyone to start doing that early, and to avoid any congestion on Fridays, right? And project report, right? We will have some milestones. Your project will be broken into several milestones, and we request everyone to submit a report and also make a private GitHub repository and upload your code. And because our TAs will not only look at the reports, they're going to look at your code. Right? You cannot fake your report. Very probably they're going to run your code. And also we'll have one light final exam, right? So we won't have midterm exam, and won't have like very serious final exam. I think exams are most useless things to check whether you have learned something, right? And I don't want to increase your stress, workload at when the semester starts to end, right? It's not necessary. We have a very light final exam, and it's very likely we're gonna do some online final exam on Canvas, so nobody needs to like get up early at 7 and then drive here or take bus here and stay at this cold classroom in the early morning to finish 2-hour class. And I think that is too cruel to everyone, including me. Right? So we'll have very light final exam on Canvas, so everybody can get up early and do things quickly and it won't take too much portion final grade. But it's just to help out to enforce everybody to give a comprehensive review of what they have learned throughout the semester, right? And the most important part are the homework assignments and the project. Any questions so far? Before we proceed to the details about this requirement. Okay, so here I just want to share some kind of like a warning message, right? This course is viewed as some kind of most challenging courses in CS department. I was receiving complaints nearly every year about this, right? But I'm not trying to lower the workload. I'm not trying to lower the difficulty because I think it's important for it is important to for you to really understand what is machine learning, what is the underlying philosophy of this area. And another complaint I've heard is the workload is heavy, partly because I request the students to implement things by themselves rather than give you some sample code or just ask you to fill blank without debugging. I think this is not a real machine learning course, right? It's more like a reciting class if I do things like that, right? Several students have complained before, it was too heavy and it probably can take their 20 hours per week. I think this is the most extreme case. I just pasted here in case in the future someone complain to me too much about this. I would say like if you really keep an efficient learning behavior and try to finish the work, try to start doing the homework assignments early, and try to leverage our office hours. It won't take this much time. Probably it will take 6 hours, no more than 10 hours, right? That's the in most cases. But there are several difficulties I've seen before. If you do have such difficulties, you feel okay, it's too difficult and it's I feel too uncomfortable, and please come to me as early as possible, right? And if you want to withdraw the class in the middle, I'm totally open to that. But don't try to come to me at the end of the semester. That'll be very hard because I remember at some time point, if you want to withdraw the class, it needs not only from my approval, but also need from approval from department head or dean, whatever. I will bring additional troubles for you, right? So again, I don't want anyone to feel being tortured. I want everyone after this class, they kind of feel like, okay, it spends me some efforts. It takes me some time to do that, but I earn something. I feel like my efforts is worthy, right? Is worthy, and I got I got what I want. This is the most ideal situation, right? But if you don't feel right at any time, or if you feel challenging at any time, or if you confuse at any time, uncomfortable at any time, please come to the instructor as early as possible, because that will benefit you. I do see some kind of challenge cases before. I don't want anyone to have trouble on that and to feel to have too much stress on that. Right? You can take, if you feel like okay, you're not very well prepared for this class, you can take it next time. Right? We have this class every spring and fall semester. It's a fundamental class. It's always open. Okay, any question? Everyone feels comfortable? Okay. So, okay. So next we're gonna start talking about the structure of this course, right? So please bear with me some kind of, we need to spend some time to go through the structure of the course and then the requirement of this course to make sure everybody is posted, right? And clear about the requirement, and so that you have enough preparation to take this class, or you can decide to quit this class as soon as possible to avoid any, loss, right? Because everyone, I know you guys are multitaskers, you are taking multiple classes. You should optimize your schedule and by yourself, right? I don't want to give you any misleading or let you miss some important information, right? Okay, so so first we have a course website. So the course website actually contains all the detailed information and also gives the link about the syllabus. But syllabus is basically kind of same of the course website, but it is more formal because we're required to provide the syllabus, right? So the course website, I'm gonna quit this. Yeah. So the course website actually is literally on the homepage. Let me okay. So it is right on the homepage of the instructor. So if you cannot find my homepage, it's very easy. Just search my on Google. I think the first entry will be me, and look at there's a teaching section. There's a link to the course web page, and then this course web page contains everything, right? So you see that. By the way, is it clear to everybody? I can enlarge the font. Does it look clear for everyone? Okay, so you can see the schedule here. Of course, it's Tuesday and Thursday in this classroom from 9:10 to 10:30, right? So this is final exam, right? And it's on Monday, December 9 from 8 to 10 a.m. And this is scheduled by the university, it's not by me, right? And you can check the official schedule here. Right? This is the official page. You can verify that. I've verified it a few times, but if I were still wrong, please let me know, right? So, and the instructor is me, and this is my office, right? And this is where I give my office hour, right? And we have three TA, and Jia Cai, Keyan, and Matthew Laurie. And later we'll release their office hours. And right now we're trying to schedule the particular office for their office hours. And their official office hours will start from tomorrow, right? And but we'll make an announcement in Canvas. Oh, by the way, sometimes the TAs might not be come to the office in person, and then they're gonna use some Zoom link, right? So virtual office hours, they're gonna make announcement in Canvas. Please just watch your Canvas link, and sometimes they might have their personal stuff, so they kind of make it in a normal time. They're probably gonna reschedule it at some time. But again, please notice the look at the Canvas notice, right? But here I want to emphasize that we literally trying to schedule the office hour for every weekday, from Monday to Friday. Every day we have an office hour, and especially on Friday, we'll have a 5 hours for Q&A. Again, please fully leverage those resources. Although according to our past experience, 95% office hours are just empty. But again, I want to emphasize, please leverage this and help you, and to help with your learning efficiency, to help you resolve your problem, right? And here you will see the link to the syllabus, right? So this is the syllabus, right? And again, I'm gonna enlarge the fonts, right? So the first link is a course web page, right? Okay, again, you can also find this link to the syllabus in Canvas. If you look at Canvas, there's a page, and you see their link to the course website and link to the syllabus, right? And also teaching assistant, the office hour. I will update shortly about the office hour schedule. And this is a description of the course. So I don't want to read those sentences of description, but here I just want to emphasize what to expect. I mean, after taking this class, what is expected outcome? We hope that our students, after taking this class, will be able to understand the machine learning ideas and paradigms, right? Without just run existing libraries, right? Second, we'll have like principles and ideas about how to identify appropriate machine learning problems for research or your application, right? So you see that actually not every method needs to be addressed by deep neural nets, right? And in many cases, actually, traditional machine learning algorithm works even better. Like even in many medical applications, deep learning won't work, right? And the most popular methods are random forest, which we're going to discuss in our class, right? In small data regime, kernel methods is often much more robust and much more reliable, right? And third, we hope that you're well prepared to start designing new machine learning models or implement learning algorithm by yourself if necessary, right? We're not saying like, okay, you are able to develop a new machine learning algorithm. However, you have learned from our class, you're able to develop or design new algorithms and make some substantial changes of the existing algorithms or architectures, and then make your improvement. So hope that after taking this class, you will gain such capability. Okay, books, right? So we don't have designated textbooks for this course, right? So all the course, the lecture slides are self-contained. They will cover all the content we're gonna cover this class, right? So that means like if you want to review our class, you just look at the lecture slides. That should be sufficient. And sometimes we're gonna do some. I'll use my iPad to showcase some deriving and computation procedure. For example, when we talk about backpropagation, right? I'll give you some example how to do backpropagation from scratch. And then I'll use iPad to say draw a 3-layer neural networks and show step by step how to implement a backpropagation algorithm. And in that case, I will also share what I have wrote and also share the lecture videos of doing that. Right? But if you want to extend your knowledge, you want a further study, if you do require some like additional books, here's a set of references. You can take a look. Right? Those books are all released online. You don't need to buy it. You can download them from the website. And again, if you're interested, you can take a look because all those books are very thick and very heavy book, and you can use them as a big reference, right? I don't suggest you to read page by page. You won't have enough time doing that, right? Okay, prerequisite, right? So the prerequisite here is just to assume that you know basics about probability and statistics. And you're familiar with linear algebra and vector matrix stuff, right? And also you have some basic skills about algorithm design, programming, and debugging. Right? So because this is again, as we emphasize, this class is not just show you some algorithm table. Right? They ask you to implement things. Right? So basic algorithm design debugging technique are required. Right? If you have a strong problem in that, you should let us know as early as possible. Right? And also to introduce those basic knowledge like stochastic gradient descent, and also backpropagation, you do need to know what is linear algebra, right? What is statistics, right? And when we talk about stochastic gradient descent, we're going to explain why doing stochastic gradient descent is correct. Right? They need to know the basic concept about the gradient and expectation and variance. Does it make sense? Okay, getting help. This is really important. We strongly encourage everyone to take advantage of the instructor and TA office hours. We'll update soon in the course webpage. That means we have an office hour every weekday, especially long office hours on Friday, because most deadlines are due on Friday. We'll work hard to be accessible to students, right? And but sometimes if you cannot make it in office hour, you can still ask questions on Canvas, right? And we'll also allocate time for TAs to answer questions on Canvas, right? But again, we encourage you to meet with me or TAs in person in office hours, because face-to-face conversation is always the most effective way, most efficient way for communication, right? And don't be shy if you don't understanding something, right? That's very common, right? To catch the pace, right? To ensure like we can finish everything, right? We cannot ask everybody to raise a question at every minute, right? We try to make everybody to catch up, right? But sometimes if you miss some point, that doesn't matter, right? Just ask us, right, during office hours or in the Canvas Q&A. Like, feel free to post questions regarding any question related to the class in Canvas, right? About homework, schedule, material covering class, right? And feel free to answer questions. Again, this is just to try to raise a active learning environment in Canvas, right? We encourage you guys to discuss throughout Canvas. There's only one red line. You cannot post your answers to Canvas. Like somebody will ask, okay, I don't have any clue of solving homework 1, right? You cannot just paste your answers. You cannot just upload the PDF and writing and showing, okay, you should calculate this or calculate that. No, you cannot do that. You can give some like a hint, like you say, okay, I believe using some theory or using some conclusion discussed in the class can address this, and that's it. Right? You cannot give the full answer on that. If you happen to give that, it will be deleted by our TAs, right? And you get some warning on that, right? However, if you discuss offline, you can talk about details. The reason is that when several of you like stay as a group, as a study group, right, and trying to work out those problems, if you don't understand, because you communicate with each other, right, you write on a board or whatever, on papers, right, you understand, your fellows understand, right, and then you write everything by yourself, and that can truly reflect that you understand that problem. That's fine, right? But online, you cannot post the details, detailed answers from your perspective, because you cannot avoid somebody else just copy and paste. Does it make sense? Just email to the TA. No, we won't post the answers publicly. The reason is very simple. If you pass it, and it's gonna be spreaded by in the future, and no one will treat this seriously. If you feel like, okay, that's a good question. So if you feel like the grading is not correct, or you feel uncomfortable, you can request regrade after the release of the grade within 1 week, right? And if you don't know the answer, you want to know the answer, please bring the homework to the office hour, and discuss with the TAs, and they will give you the right answer, right? But unfortunately, we won't release the answers to the homework assignments publicly. Any other question? Yeah. All the remaining lectures, I mean, for all the remaining homework assignments, the content will be fully covered by the lectures, right? And of course, we won't teach you how to write a program from scratch. That's your task. Any other question? Okay, great. Yeah, okay. I think we can stop a little bit early today because we're gonna briefly introduce the tentative course schedule, especially what kind of machine learning framework and algorithm we're gonna cover next time, and then what is the grading policy, cheating policy, especially ChatGPT policy, next class. Okay, see you on Thursday. And again, please start looking at homework 0. Not necessarily do it today, but start looking at will not be bad. Right?